Hello, students. Welcome to Lesson 4. I'm your teacher, Ellie Daniel.
In this lesson, we will be discussing the Pythagorean theorem. We have 3 essential questions today. Our first is to explain the history of Pythagoras and his most famous theory, the Pythagorean theorem. Our second essential question is, how can I use the Pythagorean theorem to decide if 3 lengths would form a right triangle? This is one use of the Pythagorean theorem. And the second is, how can I use the Pythagorean theorem to find an unknown length in a right triangle? And this is the second purpose of the Pythagorean theorem. So let's first think about what type of angles ancient civilizations would be concerned about and why. Well, given the pictures down here, you can start to think about the why as building purpose. But the angles that they were concerned about were right angles. Right angles were important because all buildings were built with right angles to ensure stability, and studies of right angles date as far back as 1100 BC, which is over 3,110 years ago. So you can see that you're not the first students to study right angles. As a matter of fact, many students before you have studied them as well. The first study of right angles was by the ancient Egyptians. They were interested in forming right angles at the corners of their pyramids and their other buildings. And we know that they were really successful at that because we see those buildings still standing today. Well, what the Egyptians discovered that made their building so successfully firm was that a triangle existed with side lengths of 3, 4, and 5, and if it had those 3 side lengths, then it formed a 90-degree angle, and they used this fact to test every corner of their pyramids and buildings. Now, the Egyptians did not use or discover the Pythagorean theorem. They did not even realize what Pythagoras found. What the Egyptians knew was that there was one right triangle that existed. As a matter of fact, they thought that the 3, 4, 5 triangle was the only way to form a right angle, which was not true. Okay? But it did help them build their buildings very sturdy. Now, the Egyptians' 3, 4, 5 triangle, they actually created a tool that they could use in carpentry to test every corner of their building. To make sure that they had 90-degree corners in their buildings, they used a rope made of horsehair with 12 evenly spaced knots. If you look at the 12 evenly spaced knots, if you hold them along the first, the fifth, and the third from last knots, you can see that there are 3 even spaces on one side, 4 even spaces on the other, and 5 across the longest side, which is called the hypotenuse. And you can see here is a right angle, so you can see them testing it with this portion of the triangle. This understanding of 3, 4, 5 triangles is what allowed the Egyptians to build perfect corners in their buildings and pyramids, and is the basis for why we can still view them today. So, what did Pythagoras find, and when did he come about? Pythagoras found that not only triangles with sides of 3, 4, and 5 make right angles, but that there are infinitely many triangles that make right angles. In other words, he proved there is more than one way to make a right triangle. And here was his theory. He found that any triangle has a right angle if, when the 2 shorter sides in a right triangle are squared and then added, the sum equals the square of the longest side, also known as the hypotenuse. Now, what this looks like algebraically is a squared plus b squared equals c squared. A and b are known as the legs of the triangle. The legs of the triangle mean the two shorter sides. And if you want to remember it this way, think about ABC order. A is going to be your shortest side. B is going to be your medium length side. And C is always going to be your longest side, which has a special name called the hypotenuse. So what his theory here is saying is if you take the legs and you square them, meaning you multiply them by themselves, it will always equal the longest side multiplied by itself if it has a right angle in the triangle. Now, back in those days, people didn't embrace educational change. So when Pythagoras posed his theory, it was immediately rejected. As a matter of fact, he had to prove his theory 84 different ways. 84, can you imagine? That's perseverance there. 84 different ways before it was accepted by his peers. Here is one proof that you can use to see that a squared plus b squared equals c squared. Let me get it to start over. Okay, so here you see your right triangle in the middle. You can see that the short side has become a square, the medium side has become a square, and the longest side has been used to make a square. You can see they brought the b square over and laid it on top of the c's square and brought the a square to the center. This proves that the a side squared and the b side squared will always equal the c squared. See how it's forming to create an equivalent amount. Now, I don't expect you to understand the proof, but I do just want you to know that Pythagoras went above and beyond to prove his theory, and this is just one way for him to do it.